So, my dear students, today what I discussed that already you know that already 4.5 units are completed. Now today we are discuss about that the last unit of that analog Cmos IC design, and obviously that today's topic what we discussed that how to design that the op amp, how to compensate the op amp, and that the small signal dynamics of two-stage op amp and Miller compensation of two-stage op amp. So this is the four topics I try to discuss today. Let us see up to which now the first topic is that design of op amp. So what is the design of op amp? Design of op amp means we have to design some op amps based on that the design of that whatever the structure we are selected. We are selected here the two types of structure. One structure is that divided into two distinct design related activities, and another one when the designer is select DC currents and begin to size the transistors. And obviously if you see that the actual design of an op amp we can start through that one must set all of the requirements and boundary conditions that will be used to guide the design. Now, for the design of op amp, we require that some of the items are to be considered. Now, to design of this consider, we require that two types of condition. First one is require that boundary condition, which consists of 4 items, and then for the design of op amp, we require 12 requirements, and based on these 12 requirements, we are design any CMOS op amp. That means complementary metal oxide semiconductor op amp. Now, what is the boundary condition? Boundary condition is specify that what is the process we require, like that the threshold voltage, that oxide capacitance, that transient parameter, that the parasitic voltage, all this type of whatever that the specification are required for that any type of design of CMOS. This is first boundary condition. The second boundary condition is supply voltage and range. Third one is supply current and range. Fourth one is operating temperature. And what is the range of operating temperature? Now, what do you mean by range? Range means that will be what is the lower limit and what is the upper limit. That there will be, we can't tell that this is the lower and upper limit, but we can tell that is some of the percentage based on that the minimum voltage. So based on that minimum voltage, we can tell some of the supply voltage and supply current and operating temperature with their range. Now, this is the first condition, that is boundary condition. Now, what is the requirement? There are required 12 requirements. What is the 12 requirements? The first one is gain. Second one, gain bandwidth product, settling time, slew rate, ICMR, input common mode range, CMRR, common mode rejection ratio, power supply rejection ratio, output voltage swing, that is required for the measurement of the slew rate. For measurement of slew rate, we know that how to measure the slew rate. Slew rate is nothing but the rate of change of output voltage with respect to rate of change of time. So, for the rate of change of output voltage, we require that output voltage swing. How much the output voltage is changed from T1 to T2, T2 to T3. So based on that the output voltage swing from that one time to another time, and what is that the difference of that the output voltage, from that we can measure the slew rate. Next one is output resistance, or sometimes it is called output impedance. Now the base one is output impedance or output resistance. Basically we can measure all these parameters from the small signal analysis model. We can't measure any type of output resistance from large signal analysis model. So the students, when in the next page, when we are discuss about all these things, so this is the output impedance or output resistance we can measure from that all that the output at all the small signal analysis. Now next one is offset. Offset means offset voltage or offset current, whatever. What do you mean by offset? Offset means without applying any input voltage, if we got any output, that is called that offset. For ideal op amp, if we don't apply any type of input, we don't get any output. But in that the world, nothing can be ideal. All will be practical. So whenever we design any type of Cmos op amp, we can't design any type of ideal op amp. Whenever we are trying to design ideal op amp, but we can't design, we have to design that the practical op amp. So for that practical op amp, we require that how much is that the offset voltage we are considered for that op amp, and there will be noise. Now noise will be different types of noise are there. Additive white Gaussian noise, spectral noise, power spectral noise, all these type of noise are there. But here we are measure only that what are the effective noise are created due to the design of op amp. And the next one is that layout area. So this one is that the boundary condition and requirements are required for design all this type of thing. Oh, so this one is that the last time, this is that the table in that the right hand side of your screen is showing that there are the table and there are some of the values which is required for that, and this is called that the ideal values when we are specified for design any types of op amp. Now for designing any types of op amp, we have to start some of the feedback point or feed forward path point. Now in designing of op amp, one can begin at many points. The design procedure must be iterative, and there will be three types of stages are there. First one is differential stage, second stage and buffer stage. So we have to require, there are basically when we design any type of typical CMOS, we are required that three steps are required, very appropriate. First one is decide on a suitable configuration. Second one, determine the types of compensation that should be needed to meet the specification. And third one, design device size for proper DC, AC and transient performances. Now what is that first one? Decide on a suitable configuration. The decide on suitable configuration, it is required for that to determine what type of configuration is required for design of op amp. Now if we require extremely low noise and offset, so we require high gain of input stage, and for that we require class AB type of output stage. Now what is the second one? Determination the compensation. That means what type of compensate amplifier we are required for types of to meet the specification. So this one, all this type of, and what is that the third one? Third one is design the device, proper device for DC, AC and transient response. It is required to based on the approximate design equation. Compensate components are also sized in the step of procedure, and each device is handy and circuit simulator is fine-tuned design. So if we summary the design process, it is consists basically that two major steps. The first is conception of design, and the second one optimization is optimization of the design. The conception of the design is accomplished by proposing an architecture to meet the given specification, and this stage is normally accomplished using hand calculation in order to maintain the viewpoint. And the second step is to take the first cut design and verify, and it have to be optimized. This is normally done by computer simulation and can include such influences as environmental or process variation. So this is the total complete of the design of op amp. So in the next class we are go for that compensation of op amp. Thank you.